Okay, finally, a cat is selected at random from all 160 cats. Find the probability that the cat was female, given that its weight was over 4.7 kilograms. Okay, this is obviously a conditional probability question, guys, because it says given that. When you see given that, it's definitely conditional probability. Now, you could do this without a tree diagram, but I think I'm going to use a tree diagram to help explain it, and there's certainly no problem using a tree diagram in your exam. In fact, go for it. It might help, and you get marks for it. Okay, so this is, the tree is male and female, and then over 4.7, over 4.7, or under, let's just do the greater than, guys, greater than 4.7, less than 4.7, and then female, same thing, greater than 4.7 and less than 4.7. Now, over here, just a reminder, the males were normally distributed with a mean of 6.1 and standard deviation 0.5. Guys, that is not right. It should be 0.5 squared. And the females, 4.5 and 0.45 squared variance. So, firstly, there's 160 cats, 80 are male and 80 are female. What's the probability of getting a male? Well, it's half, 50-50, or 0.5. For the males, the probability that it's more than 4.7, now guys, you just simply have to do this again. So we need to go menu, because we didn't get this in any previous question. Distributions, normal CDF, 4.7, 99999. Mu, let's do the males first, 6.1 and 0.5. You would expect this probability to be high, and it is high, 0.997445, 0.997445, and then you want to get the probability that it's not that. So if you just do -1, guys, answer -1. Obviously this is negative, but it's the positive version we want. So 0.002555, 0.002555. Is that what I said? Yes. What I mean by, guys, obviously it's negative, is because I should have done 1 minus this, not this minus 1, but it's just easier. My calculator. Anyway, females, same thing. I can even just copy and paste this, guys. Copy, paste, and change the 6.1 into 4.5, and change this into 0.45. Okay, yeah, you'd expect, well, you definitely expect it to be less than 0.5, which it is. So 0.328361, 0.328361, and then this, again, same thing, guys. Answer -1, 0.671639, 0.671639. Okay, I haven't rounded here, guys, as you know, don't round until the end of the question. Okay, so the probability that it was female. So what I'm looking for is the probability that it was female, given that its weight, let's say let's use weight, W for weight. Weight is more than 4.7. Using the conditional probability formula. This is the probability that it's female, and so it's the probability that it's female and its weight is more than 4.7 divided by the probability that W is greater than 4.7. If you don't know how I did this, guys, get out your formula booklet. It's straight out of the formula booklet. It's A given B. It's A and B over the probability of B. Okay, female and weight greater than 4.7. Now the reason the diagram is nice is female and greater than 4.7 is just this times this. So it's 0.7 0.328328,361 times 0.5. That's 0.164181. 0.164181 divided by the probability that W is greater than 4.7, right? So that's, well, it's this times this plus this times this. So it's male and greater than 4.7, or this times this, which, sorry, female and greater than 4.7, or male and greater than 4.7. So it's actually just going to be this again, 0.164181 plus this times 0.5, which is 0.997445 times 0.5 gives me 0.498723. 0.498723. Put all that into my calculator and I get 0.164181 over 0.164181 plus 0.498723. Press enter and I get 0.247669. 0.247669. Okay, that's it. That's the probability that the cat was female given that its weight was over 4.7. And think about that. Does that make sense, guys? You get a cat and it's quite, well, it's quite a heavy cat. Well, maybe you'd say it's quite a heavy cat. And you'd say, okay, it's more than 4.7. What's the probability that it was female? Well, yeah, it makes sense that the probability would be certainly smaller than 0.5. But so that answer, as I always say, guys, I like to check, does an answer seem reasonable? And I think in this case, it does.